Teja.
All right, so do you see it's recording now?
Yes.
Yes, I see that.
All right, so let's go ahead. All right, so thanks for coming to the Data Science Club today. So just talk a little bit about myself. So my name's Stephen Herrera. I am the president of this club. I went to the University of Texas at Austin, where I got my undergraduate degree in a Bachelor of Science in Physics. And at the university, I studied stellar evolution research. And during this research project is where I really discovered the wonderful world of data science, as it were. I learned Python and just really cool like data science things like machine learning and pre-processing and all that kind of stuff. And that's what really got me started in the data science world. And so after that project, I decided, hey, well, maybe I want to continue down this path. So I decided to pursue my Master of Science in Cloud and Big Data Solutions here at the University of Houston, Clear Lake. And next, Ratna.
Yeah, I'm Ratna Teja and I'm vice president of this club, and I'm currently pursuing masters in data science, and I wanted to pursue minor in cloud and big data solutions. And I did my BTech at Good Lawler Engineering College in information technology BTech. So during my undergrad, I was one of the student peer mentors at Department of English and one of the members for class monitoring committee, and I was also a member of Saint, which is basically a student association for our department. So yeah, that's it.
All right, so the purpose of this club is to assist our members in the data science job market, as well as learn about various data science topics and skills, and to foster a sense of community here. And that brings us to our next slide, our interview question of the day. So this is going to be a recurring segment here at the Data Science Club. So I have a collection of real interview questions that were asked by real employees in the data science space. And by far, the most common question I get is, tell me about yourself. So like the reasons why they ask these kind of questions are they're looking for things like why you chose data science, what kind of previous projects you've worked on, and what's next in your data science career path in your journey, right? So Anusha, if you just wanted to maybe like tell us a little about yourself, tackle this interview question of the day, that would be great. But if you don't have to.
So I'm Anusha Bailey, and I'm pursuing my master's in computer science here at UHCL, and this is my second semester here. I've done my bachelor's in India from Vasavi College of Engineering in Electronics and Communication Engineering. So I've switched to the computer science major now, and yeah, and I'm looking.
Anusha, are you still with us?
Oh, sorry, I muted myself and I was talking.
That's fine.
Yeah. So I'm Anusha Bailey, and I'm pursuing my master's in computer science here at UHCL. This is my second semester here, and I've done my bachelor's in electronics and communication engineering from Vasavi College of Engineering in India. And yeah, and I'm looking forward to being part of this data science club.
Fantastic. So one of the things I also wanted to talk about was the Kaggle State of Data Science. So Kaggle is this online place where people who are interested in the data science, machine learning, and artificial intelligence space will come together and they'll just take on a series of coding challenges and coding projects, and they'll try to work together to bring solutions. And so every year Kaggle does a state of data science where they'll ask real working data scientists in the field just like a variety of questions. And so one of the questions that they asked in 2021 was, what cloud service providers are they using? And so these cloud service providers are places like Amazon Web Services, Google Cloud Platform, and Microsoft Azure. So what these cloud platforms will do is they'll provide basically these like big data solutions, and data is getting just enormous, just absolutely massive these days, with technology becoming more and more ingrained with society, especially with the Internet of Things like remote sensing and satellite imaging, and just all these just wonderful methods of obtaining data. And we can see Amazon Web Services just is the leader in this space right now. And I've also included a link. If anybody's interested, they can just copy that link and go to the full report where Kaggle has just all the questions that they asked these data scientists. So we also have social media. This is our social media link tree. So we have our UHCL Get Involved page. We have our Discord, our Twitter, our Instagram, YouTube, and Facebook. So we are recording this meeting right now, and it'll be uploaded to YouTube. So if anybody misses a meeting, they can always go over there and check out what happened in the last meeting. And we'll try to do this at least every single time we have Zoom meetings, and whenever we have in-person meetings, we'll try to do that as well. So I'll just give anybody a minute if they wanted to go ahead and scan that real quick using the camera on their phone. Okay, so we have officer positions open. So if anybody wanted to join the data science club as an officer, you can email me or Ratna. But this brings us to the coding portion of our meeting. So here is predicting customer spending behavior. So
Hello, Pooja. Pooja just joined.
Hello, hi.
yes. Hello, Pooja.
Hi, Steven. How are you?
I'm great. How are you?
Yeah, I'm good too.
So yeah, we're recording the meeting. So just in that case, if anybody
Pooja.
wanted to
Hello.
see these meetings after the fact, or if you miss a meeting,
Yeah,
then
sure. I think
yeah.
I missed 15 minutes like meeting, so I can go through that.
Yeah. So this is our social media link tree. So this is gonna take you to a link tree where it has all the links to our social media. So as you can see, there's YouTube on there. So we're gonna upload this video to YouTube. So you can definitely check out anything you might have missed right there. And you can join our Discord so that we can always be in communication between the club and our members. So if you want to stay up to date with whatever is happening with the club, you can join our Discord.
Thank you, Steven.
So yeah, we were just about to head into the coding portion of our meeting today. So this is predicting customer spending from behavior. So this is going to be an implementation of linear regression. So I'm just going to go ahead and assume very little knowledge in Python, just for like anybody who might be just starting their data science journey here. So this is called a Jupyter Notebook. This is a really popular coding environment in IDE, interactive developer developing environment. So if you wanted to learn how to code, this is a really good environment in which to do so. So of course, the first step is to import our necessary dependencies, right? So we're going to load our Python libraries. NumPy is very popular for data manipulation for things in linear algebra like matrices and tensors and things of that nature. And then next is another data manipulation library called Pandas. This is extremely popular. It's really good for imagining data frames. So, and it's very similar to an Excel spreadsheet. And then here are some popular data visualization libraries like matplotlib.pyplot and Seaborn. So first, we're going to have to read in our data, and DF right here, that stands for data frame. That's a very common way to write your data frames. So what we have here is the e-commerce customers data set. And so this is written as a CSV file, which stands for comma separated values. And Pandas has a really neat way of reading this special type of file called read CSV. I forgot to mention really quick that these right here, so whenever you import your libraries, you can go ahead and alias them. So an alias is just something that is shorthand for something for your library. So in this case, NumPy is the full name of this library, and then I just call it NP for short, and that's called an alias. And I do these with all these libraries mentioned here. So when you see pd.readCV, I'm simply grabbing the read CV function from the pandas library here. And then so we can display the first 5 rows of our data set here. And so you can see we have these different features here and the yearly amount these customers might have spent. And so the standard is for 5 rows to be displayed, but you can go ahead and come in here and say, let's say you wanted to display 10 rows, and it'll display the first 10 rows. Notice that it does start at 0. So it's going to end at 9, and that's going to be your 10 rows. But the standard is 5. So a really good way to do some quick and dirty calculations. Pandas has a really neat way of doing descriptive statistics. So here you can do dataframe.describe. So that's going to go back to the data set that we read in here. And describe will take all of these numerical columns here and just generate some statistics. So count, that's the total number of observations or rows that we see in our data set. So you can see each column has 500 rows. And then so we have the mean, also known as the average, the standard deviation, the minimum values in each column. And then so this is the 25th percentile, the median, the 75th percentile, and then the maximum value. And then so if you want to see how these different columns are related to each other, you can do a correlation matrix. Again, this is from the pandas library. You can do the dataframe.core, and it'll show you the various correlations. So these will run from -1 to 0. As you can see, we do have some negative numbers here. So the negative means that the correlation between, let's say, average session time to the time on the app is negative. So that means that they're negatively correlated. So you can imagine a line going from the top left to the bottom right. And so when it's 1, that means they're completely positively correlated. So time on website is 100% related to time on website, given that it is the same column. So sometimes you want to see the metadata of your data set, and a good way to see that is by using the .info from pandas, and it's going to return to you the names of all the columns and all of the observations that are not null. So we can see 500 of the values are not null. So we have like no null values or no empty empty values in our data set. And then so you can see the type of the data type of our columns. So object, object, object. So what that would mean in this case are these are all strings or just like text values. And so we can see here float 64 that all of these columns are numerical columns or floats. So some exploratory data analysis is a really good way to get more into the nitty gritty of your data set. So if you wanted to see variable relationships or the relationships between one column and another and how these numerical values are distributed amongst the data set, you can use a joint plot. So here we can see I loaded the data frame and the values that I want to get from these data frames are the time on the website column and the yearly amount spent. So you can see that these values are more or less normally distributed. And you can see that there's not too much of a relationship between these two values. So next we choose the time spent on the app and the yearly amount spent. And you can draw a regression line on this plot for using the Seaborn. So these came from the Seaborn library, which I aliased as SNS. And so you can see that this right here will create a regression line. So it'll have these lines over here. And you can see we do have some correlation. It looks like there might be a line there. So we might want to explore that. Hello, Jennifer, can you hear us? Okay, I think she might be still trying to load in. So next is going to be the hex bin plot for density visualization. So let's say you have a lot of points that are overlapping, correct? And it might be hard to tell one point from another. So joint plot from the Seaborn library has a really good way of imagining these densities or visualizing these densities. So you can just change kind to hex for these hex bin plots. And you can see that there are some data points that are densely distributed in these darker regions of the graph. So let's say you don't have too many columns, but you don't want to have to type all of this code out, right? Like you don't want to put that much effort into these visualizations. So Seaborn has a really good way of drawing every single plot against every single column against every other column for a plot. And that's called pair plot. So it's going to grab all the numerical features from your data set. And you can see here every single column matched against every other column, every numerical column that is. And whenever these columns are matched up against itself, we can see these histograms across the diagonal. So you can see how that column in particular is distributed amongst your data set. And so we see here that the yearly amount spent and the length of membership here as well. We can see that there's some linear relationships going on here. So what we're going to want to do is split these data sets into training and testing data sets. So it's usually good practice to create a copy of your data frame. You always want to just kind of leave your original data frame intact. And so what I like to do is I just like to df.copy, and that's going to copy my data frame and assign it to the variable customers. And then so you can choose your features columns. And so here I have my features columns. And of course, I grabbed that from the customer's data set. And in this case, our target column is going to be the yearly amount spent because that's the point of this entire project, right? We want to predict how these different variables might affect how a customer will spend their money at a particular location on a website. So whenever you're building your linear regression model, you want to prevent your model from overfitting. So the way that we do that is we use train test split. So what that's going to do is it's going to take your data set and it's going to split it in different amounts. So in this case, I'm going to do an 80-20 split. So 80% of my data will be training data and 20% of it will be the test data. And that's gonna give us a tuple, and that looks exactly like this. So here's my training data, here's my test data, and then these are the target variables, right? So this would come from the yearly amount spent, and this is going to be the training, and that's going to be the testing. So you might wonder, what is random state? So whenever train test split happens, it's going to split it randomly, but computers, these are deterministic things, right? You can't really tell a computer to be random. So this is kind of to control this randomness in the data. So let's say if you have random state equals 105. So it's going to use this number in its algorithm to quote unquote generate randomness. And it's always going to use this particular method of generating the randomness. And the reason why you might want that is for reproducibility. So let's say you train a model and then you might want to use the same rows to do an apples to apples comparison with maybe another modeling method, because you want to use the same observations as before. Because if you're using different observations, then because of this random shuffling that happens in the data, you might not really be comparing apples to apples. So this is a really good way of making that apples to apples comparison. So now we're gonna train our model using linear regression, right? So I import linear regression from sklearn, and I assign it a variable. And then because I've already used the split, right, I can just go ahead and put that into our model and do .fit. And then I can get the relationships between our different feature columns and our target. And so I can just print those results here. And so let's try to make some predictions. So I'm going to take the testing set and try and see if I can predict what the Y values might be. And this is super straightforward. I can just do the linear regression model.predict, and it's going to do all the heavy mathematical computation for me. That's really great. And then so we can use a scatter plot from matplotlib to visualize our real test values versus the predicted values. So these are the values for our testing set, and this is what we predicted. And we can see that they're pretty close, obviously not perfect, but we can see that there's definitely a line going on. So now we want to evaluate our linear regression model, right? So sklearn also has a library for that. So I can import metrics from sklearn, and this is how you would import different classes from different libraries. So root mean squared error is usually typical for evaluating regression models. One of the things that you have to keep in mind when using root mean squared error is that it penalizes larger values more harshly. So what do I mean by that? So that means if we predict a result to be 5, but instead we get 10, then root mean squared error tells us that the error is 5 minus 10 squared, right, equals 25. But if we predict 8, then the root mean squared error is 8 minus 10 squared equals 4. So we can see that there's a pretty dramatic difference between 25 and 4. And Another way of evaluating your model is by using the mean absolute error. And this is more forgiving than the root mean squared error because the error is proportional to your prediction minus the target, and it's the absolute value. So it's always going to be a positive number, just like the root mean squared error. And you can implement these methods here using NumPy has the square root function. And we can see that this is how I implemented it with the ground truth, our testing data, and the Y values or the target values that we predicted. And we can see root means. And another way of evaluating your model is by using R squared. And this tells us how much of the variance is explained by our feature columns. So this is telling us something different than root mean squared error and the mean absolute error, where these are telling us the errors, and this is telling us how much our feature columns explain what we were trying to grasp, in this case, the customer spending. And so we can see here that the root mean squared error is about 10.5. The mean absolute error is about 8.3, and the R squared is 0.97, which means that our target values explain about 97%, 97.8% of the variance, which is pretty good because the closer it is to 1, the better. So which one might you want to use? And this really depends on your use case. If your model can't afford large margins of error, then root mean squared error may be preferable to the mean absolute error. And so now we can go ahead and interpret our coefficients. So we can go ahead and make a really good way of visualizing this by using a data frame. So we can create a data frame from pandas right here, and this will load up our coefficients, and this will load up the names of those coefficients or what those coefficients are associated with. And I can just go ahead and show y'all right here. These are the different values. So what do these mean? So our coefficients represent the increase in dollars spent for each unit increase of its respective attribute, given all other attributes are held constant. So for example, a unit increase in average session length results in a $25.78-ish cents of money spent, given that we held all of these attributes constant. I've gone a little bit over time, but if y'all wanted to dive a little deeper into linear regression or any of the libraries or methodology that I've explained here today, I do have this reference section here. Here is our link tree. So I forgot to mention that our GitHub is also here. I will be uploading the code I've just presented to you to our GitHub, so you can dive into that deeper and play with it however you want over there, provided you have a GitHub account, of course, which is free. So there should be no issues with that there. But once again, we are looking for officers. So if you're interested in becoming an officer of the club and diving even deeper into the data science space, you can email myself. This is my email right here, or you can email our vice president, Ratna. But thank you for coming, and that's all I have for you today. Is there any questions from anybody?
I have a question. Hopefully you can hear me.
Yes, I can hear you.
Are the meetings going to be at this? And I came in late. I apologize. I have a conflict that I managed to wiggle out of this time, but I was late. Are the meetings going to be at this time always, and how often?
So the meetings we're trying. So yeah, the meetings we're trying to have at least once every 2 weeks right now, because it's only me and Ratna. I mean, we also have other obligations as well, right? So because it's only the two of us trying to, essentially build this club from nothing, we get a little crunched on time. So right now, I think doing this once every 2 weeks is the more manageable approach for us. But we are looking for more officers, and the more officers we have, then the more often these meetings can be. As for the time, yes, we were looking to have these around Tuesdays to 12, but I also think that depends on like if everybody says, like if more often than not, people say, hey, like, I have too many scheduling conflicts during this time, then we would be open to, reschedule these meetings to another day, another time. But yeah, but for right now, it looks like they're going to be Tuesdays to 12 once every 2 weeks.
Okay, and if you end up moving them to 1, I'll be there every Tuesday. At 12, I'm going to be really hit or miss. So I'll be later, else I'll have to miss altogether. So, but
Okay.
That's just one person's vote. I don't know. I wonder if there's a way to send out like do a little calendar, like, oh gosh, a little doodle poll or something. I don't know.
I mean, because we have our did you see our link tree, the little QR code that I put up for a brief second?
I saw it for a brief second. I haven't been to anything yet, so other than just emailing you and getting on the list. So
yeah, because that's a really good point. It'd be really good to get everybody's input. So let me show that again really quick.
Can I get to it from the UH Clear Lake, from the Get Involved page?
I have yet to post it on there, but
Okay.
I can definitely post the link on our UHCL Get Involved page. Can you see the QR code right now?
I can see it. I guess I'll take a picture of it. Yeah, just a link would be awesome. Like a link to your GitHub would be really great. But I guess I can email you, right, if I can't find anything.
That's correct. We'll also be uploading this Zoom recording to YouTube. So
Okay.
have you gotten it?
Yeah, I just took a photo of it, so hopefully I can get there. So
Yeah,
that'll
but
work.
yeah,
I would really love to be involved with it. I'm just kind of getting started in this, but I have a job and classes, so,
yeah, I understand.
which everybody else is dealing with the same. And then there's no perfect time, I realize. So
Oh, thank you, Jennifer, for joining with us today. And this is for Jennifer and Pujasri. Can we have a quick intro of yourselves?
that's a good idea. I think that would be great.
Hello, hi Jennifer. I'm Pujasri. How are you?
I'm good. So did you guys already do intros before I showed up, or no? I didn't know. Because I was like,
Yeah,
oh,
we
I'm
are
sorry.
data science students doing masters in data science.
Yeah, so I just started the master's program in as well. I'm in the intro to data science class
Oh, that's great.
on Thursdays. So I'm just getting started. I've been playing with this. I teach math at a community college, but I don't know this stuff very well. So I'm working through it. So
That's great. How are you feeling?
Yeah.
How is classes going on now?
it's just the one. I like the class. I'm interested in it. I feel like it's a good fit for me. And I haven't started the first homework yet, but we just got it, and the readings are good. And I mean, I'm enjoying the class. So I'm trying to do the part-time student, full-time job situation. So I have more flexibility than a lot of people, but over my schedule, but I'm going to be just very slow. So you're in the master's program as well?
Mhm.
Okay.
Good to hear that. And we are very glad meeting you.
Yeah, nice to meet you. Yeah, a round of introductions would be awesome. Anybody else?
Yeah, thank you for that. And do you guys have classes during this time, like at 12 on Tuesdays?
I have a class that I'm teaching that ends at 12, and I put 12 to 1 as my office hours in the classroom, and I'm in the classroom like trying to help my students with projects and stuff. And so I managed to pull myself a little away this time, but I can't do that every week, you know. Like I said, if it was even a little bit, even half an hour later would help me a ton, but I know that other people have other constraints. So so that's just me. So
I don't have any classes at 12 or 1, so I'm good with this time.
Okay.
I'm also good with this time, but actually I have TARs doing in this time. So I'll try to attend every week. If I couldn't attend, I'll go through the recording, what's happening and what happened.
So is Friday good for everybody?
Yes, Friday is good.
Fridays are awesome for me because there's just less conflicts and I have a lot more control over my schedule on Fridays. You know, I can kind of schedule meetings whenever I want. So.
Okay, thank you.
Well, on Fridays, I have my part-time hours, so yeah, but it depends on the time. Like maybe I can take 30 minutes out of my time to attend the meetings. Yeah, I'll let you know if I cannot attend on Fridays.
Okay.
And Steven and Tej, I have one question. One of my friend who came in this spring, she wants to join in this club. How can she join?
So yeah, one of the best ways, she could go to the UHCL Get Involved page and she can just click, join organization, and that gives us that gives us her email address so we can send out emails to her regarding club meetings. And then we can also, like, once we have her email, right, we can send her the Discord so she can join that, and that's more immediate, right? So like it goes straight to your phone, so she could be up to the minute on what's happening within the club. But yeah, I think those are the two best ways.
Sure, Steven. I'll let her know. Thank you so much.
Okay.
What do you guys already have for officers? It sounds like you already did some of them.
So I'm the president of the data science club and Ratna is vice president, and we just have those 2 officer positions right now.
Gotcha. And sorry, I'm being just nosy here. So are these mostly graduate students or do we know?
Yeah, so definitely me and Ratna are graduate students. Anusha is a graduate student. And I believe Pooja is a graduate student as well. Correct me if I'm wrong.
Yes, Steven, I'm a graduate student.
Yeah, so I assume you're a graduate student as well.
Yeah, I am. So, and I know we don't have like an undergrad program in it, but I didn't know if there were some computer science undergrads or anything like that. Is it?
Steven, I'd like to know if, what are the other officer positions that are available right now?
I would love to dive deeper, but Zoom is limiting me to 40-minute meetings, and they say I have less than a minute left for this meeting right now. So I'm not sure if it's going to immediately kick us out in like a couple seconds.
Oh, that's annoying, isn't it?
Yeah, like they I think they want us to have like a paid account to have these longer like meetings.